Hi everybody. I'm sorry that I cannot be there today to teach you in person, but I am going to teach you via YouTube. So if you guys could please make sure you're following the directions of the substitute. Thank you, substitute. And please follow along as I go through each of the problems for this review packet and try to keep up, okay? If you have any questions, you can always pause the video and hopefully, you can get some extra guidance. One thing that I would like to emphasize as we start going over more and more review questions is you really need to be careful about reading each question multiple times to really dissect it and know what the question is and what pieces of info that you have been given. There's lots of tricks in some of these questions, so you need to be prepared. Make sure you're underlining the keywords. Do not skip that step, okay? You need to make sure you're underlining every time you come across a math problem. So let's get started here. We have a bell ringer, which says solve for C. So you have 4C equals 32. So the first thing that I want to ask you guys is, what is this 4 called? And most of you are probably saying out loud right now, it's a coefficient. If I can spell it correctly. Coefficient, all right? And that means 4 times C, all right, equals 32. That's the operation going on there. So we don't need that because we're in 6th grade now. All right, so we are going to do the inverse of multiplication to get rid of that 4. So we're going to divide each side by 4. You're going to get C equals 8. All right, so that is your answer, C equals 8. Hopefully you had some success with that. So 4C equals 32. And if we plug in 4 times 8, we're hoping that that gives us 32. When you multiply, you get 32. So 32 does equal 32, and that checks off. All right, this next one, solve for y divided by 2 equals 62. So you want to do the inverse of dividing by 2, which would be to multiply by 2. And whenever you multiply by, like that's essentially like saying 1/2 times 2, you're going to get 1y over here. And 62 times 2 is going to be 124. Okay, so y equals 124. I'm going to check that off. So I'm saying y divided by 2 equals 62. I'm going to take 124 and divide it by 2, and that's going to give me 62. So I know 62 does equal 62, and that's what I was supposed to get, so it checks. Okay, if you have any questions, please raise your hand and let the substitute know. Otherwise, we are moving forward. So before we do, here's a math joke. It says, did you hear about the mathematician who's afraid of negative numbers? Well, he'll stop at nothing to avoid them. Ha ha ha, get it? He'll stop at nothing. Anyway, you're all cringing. I'm going to move on. All right, so we already did these together. I think most of the classes left off on question 6 or 7. Let's see. So we'll go over 6. I think you guys already did this, but in case I missed a class. It says a shelf has 4 books on it. The weight in pounds of each of the 4 books on the shelf is listed below. So we're talking about the weight in pounds. Here's the list right here of those numbers. So we have a book that weighs 2.5 pounds, another book that weighs 3.2 pounds, 2.7 pounds, and 2.3 pounds. And it says which inequality represents the weight, W, of any book chosen from the shelf. So we're looking for essentially this to, oops, I did that backwards, hold on. We're looking for this to be our solution set for which of the following of these, right? So if we said the weight is greater than 2.3, in this case, it works here, it works here, it works here, but 2.3 is not greater than 2.3. So that's not going to be an option for us. So it has to apply to all of them. All right, let's try B. The weight is less than 2.4. Well, 2.5 is not less than 2.4, so immediately we can eliminate B. Let's look at C. It says the weight is greater than 3.2. Well, no, none of these are greater than 3.2, so that is not correct. when we look at D, the weight is less than 3.3. All of these numbers up here are less than 3.3, so it is choice D. All right, moving on to number 7. It says the area of the triangle below is 2/5 square foot. Find the base. Now, this was not written in your book, so please, or booklet packet, so please make sure you write that down. Right, your job was to find the base. So, it says the area is 2/5 square foot. Right, so we have the height here given. We're missing our base. That's our big question mark today. So, I know I'm dealing with a triangle. I know I'm dealing with area. So I'm going to write down what I know. Area of a triangle is base times height divided by 2. Well, that's all fine and good, but we're dealing with fractions here. So there's another formula that may be more useful to you in this case, and that is 1/2 base times height. Because remember, dividing by 2 is the same as multiplying by 1/2. So we are going to plug in what we know. We know the area is 2/5. So we're going to plug that in. 1/2 is going to stay 1/2. The base we don't know, but we know the height is 6/5. So here's our unknown, the base. And the reason I was able to flip-flop the order of the base and the height is because of the commutative property of multiplication. So now, when you are multiplying fractions, you do not need a common denominator. You can simplify before you multiply though. So I'm going to look here and I'm going to notice that the 2 and the 6 share a common factor of 2. So I can pull that 2 out of it and say, 2 goes into 2 1 and 2 goes into 6 3 times. So when you multiply this out, you're going to get 2/5 equals 3/5 times B. So we're saying 2/5 is 3/5 the amount of B, right? So that'd be like saying this much right here is worth 2/5. Well, it's kind of complicated. So if we go back to our bell ringer, I'm going to flip back a few pages. All right, we had a multiplication problem with a whole number that you guys did right here, this first problem. Okay, that had a coefficient of 4. We're dealing with the same thing. We need to divide each side by something, and now we're just doing that with a fraction instead. So flipping back to the page that we're on, if you look at this, instead of a 4 being here, we have 3/5. So we need to divide each side by 3/5. So I'm going to take 2/5 essentially and divide it by 3/5. All right, so remember this saying, you might want to write it down if you forgot. Copy, dot, flip. So what this means is you bring down the first one, copy the first term, dot, you multiply, and because you're changing that to the inverse operation, we're going to multiply by the reciprocal, right? That's when you flip the fraction upside down. So you're going to multiply this. You can simplify before you multiply. You'll notice a 5 and a 5, so that's going to be a 1 and a 1. So 2 times 1 is 2, and 1 times 3 is 3. So your answer here is 2/3. Okay, choice C. All right, it's the same process. You are just dealing with a fraction instead. Now, if you go back to the left-hand side of the screen here, we are dividing. We said we wanted to divide by 3/5. So dividing by 3/5 is the same as multiplying by its reciprocal. So sometimes if you just, some of you will be able to see this, and if over here just makes more sense to you, stick with that. But if you're not struggling with that at all, you can look here and say, okay, look, that all simplifies out. You're left with just the base, and then you can kind of save a step if it works for you. So again, you get 2/3. So I know we've practiced it mostly the way on the left here, but I think the circled blue section for many of you may just be simpler. All right, so you want to get rid of the 3/5, so you got to divide by 3/5 on each side. All right, moving on. It says number 8, which number line shows that point M represents the opposite of -1/2 and point n represents the opposite of 5/2. So again, which number line shows that point M represents the opposite? Now that was a key thing, which if you read that quickly, you may have skipped, right? So opposite of -1/2, and point N represents the opposite of 5/2. All right, some of you are probably kicking yourselves mentally right now because you probably picked, let's see, probably some of you picked -1/2, and yeah, some of you picked A, all right? A is the wrong answer because you didn't do the opposite like it says right here, opposite, opposite. All right, so we want the opposite of -1/2. So the opposite of any negative number is a positive number. So we're looking at M to be at 1/2. So if you look here, M in choice B, M is right there at 1/2. So far that's looking good. And none of these other ones work even yet. And then let's check that N, the opposite of 5/2. So I know 5 divided by 2 is going to be 2.5 or 2.5, right? So, but it's the opposite of positive 2.5. So I'm looking for that to be -2.5. So that is also represented by choice B. All right. These other bad answers are for the kids who are mixing up reciprocals and they're, thinking that the reciprocal means opposite. The reciprocal is not the opposite. All right. That is not the case. All positive numbers have an opposite negative number. That's the same distance from 0, just going in the opposite direction. And, vice versa. So if you have any questions on that, please don't hesitate to ask the substitute. Thank you. All right, we are moving on to the next one. All right, 9 is a little tricky. It says the weight of an object on the moon, M, is about 1/6 the object's weight on Earth, E. Which equation represents the approximate weight of an object on the moon in terms of the object's weight on Earth? So this is one that sounds pretty complicated. Let's read through it again and see if we can make some sense of this. It says the weight of an object on the moon, M. So if you're on the moon, you weigh M, right? It's 1/6 of the object's weight on Earth. So if you are on the M, or the moon, you're going to be 1/6 what you are on Earth. So you need to think, am I going to weigh more or less on the moon? Well, it says you're going to only weigh 1/6 of the weight. So that means you are going to weigh a lot less, okay? So it says which equation represents the approximate weight, which equation represents the approximate weight of an object on the moon in terms of the object's weight on Earth. So we know if we live on Earth, which we do, hopefully, if we're on Earth, we weigh E, right? That's our Earth weight. On the moon, it says that we're 1/6 of that. So 1/6, if we multiply, when you see this word of right here, that means multiply. I'll direct your attention to the yellow poster underneath the classroom rules board in the left-hand side of the chalkboard, and you'll notice in the middle of where it says multiplication, of is a key word that tells you multiplication. So 1/6 of E, you're going to weigh 1/6 of your weight. So when you multiply that out, you're essentially taking your Earth weight and dividing it by 6. It's the same as when we say you take half of something, you divide it by 2. When we take 1/6 of something, we divide it by 6. All right, so that's really all you're doing. So your moon weight is going to be choice B, your Earth weight divided by 6. All right, choice A is saying that your moon weight is going to be if you just take your Earth weight and you add 1/6 to it, which that wouldn't make, it just doesn't make sense. All right. And choice C, you're going to say, oh, here's your weight on Earth, just always add 6 pounds. That doesn't make sense either. All right, that's not what this is saying. Choice D is saying you're going to weigh 6 times as much on the moon that you do on Earth. Well, we've talked about the math reasons why, but scientifically why, you definitely weigh less because the gravity is less. So anyway, you're going to have m equals e divided by 6. All right, lots of fancy words when I just want you to recognize that 1/6 of a number means you divide it by 6. Okay, so we're going to move on to number 10, and it says the table below shows different possibilities for the number of games a team would need to win to maintain a certain percentage of wins. Possible baseball games won, and it has a column for number of games won versus the number of games played. And it says which ratio of, take 3, which ratio of the number of games won to the number of games played could also be included in this table. So they stop this when you're playing 70 games. Like, this could go on and on and on, just like me in this video, going on and on and on, and you could end up with this thing going on forever as long as we maintain the ratio. So let's take a look at this and talk about what the value of the ratio is that made this table. So what's the simplest ratio here? So we look at 6 to 10, right? So if you won 6 out of 10 games played. So if we're talking about 1 on top, 2 games played, we would have 6 out of 10, right? For every 6 games we won, we played 10. Dun, 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 dun. All right, so anyway, let's read this question again. The table below shows different possibilities of the number of games a team would need to win to maintain a certain percentage of wins. Which ratio of the number of games won, number of games won to the number of games played. So they want 1 first, right? They want the number of successful games to the number of games played. And that order is very important. We talked about how ratio order is super important because they're not interchangeable. Saying you won 6 out of 10 games is not the same thing as saying you won 10 out of every 6 games, which is quite impossible to do. So anyway, let's get back to this. So we're looking for an equivalent ratio, essentially, that's equal to 6 to 10. Well, if we simplify 6 to 10, that means for every 3 games that they won, they played 5. And I got that because 6 and 10 are both even numbers, and they're divided by 2 on each of those. So for every 3 games that they won, they played 5. So we're looking for a ratio that we could scale down to get 3 to 5, or we could scale down to get 6 to 10. All right. So 18 to 20. 18 to 20, is that the same as 3 to 5? Or you could say, is that the same as 6 to 10? All right, let's say you didn't simplify and you just kept it 6 to 10. All right, I know I have to I have to divide 20 by 2 to get 10. And if I take 18 and I divide it by 2, I'm going to get 9, not 6. So that first option does not work. All right, another way to check to see if these work is you could take 3 to 5 and set it equal to 18 to 20. And I could do cross multiplying and I would see if these numbers match. So 3 times 20 would be 60, and 18 times 5, when you multiply that out, you're going to get 90. So 60 does not equal 90, so that's a bad option. All right, choice B over here, we have 30 to 20. So again, number of games won, they're saying they won 30 out of 20 that they played. Well, here on Earth, if you're only playing 20 games, I don't really know how you can win 30. So that really makes no sense. I mean, heck, we'd all want to be on that team, but it's impossible to win more games than you actually played. All right, so that doesn't even make sense, just like D doesn't make any sense, because you can't win 50 games when you only played 30. Right? Again, that's something you can easily see if you read this carefully. In another scenario, it could be, games won to games lost, but in this case, it's games won to games played. So those are what I would call garbage answers, right? And choice C, 18 to 30, let's see if that works, because by process of elimination, it must be C, but let's just check. 18 to 30, if you simplify that fraction, they both share a common factor of 6, so that would be 3/5. And we said that that's what the value of this ratio table was, 3 to 5, right? So you increase that, scale that up, it's going to be 6 to 10, whatever. You could keep scaling it up, and you would end up with 18 to 30. All right, so if you don't believe me, we could do the whole, some people call it butterfly math. The technical term for it is cross multiplying. So 30 times 3 is 90, and 18 times 5, we already did that math, that is also 90. So when those two numbers match, when you multiply, that means that indeed is a proportion, and you know, it was scaled up or down correctly. All right, so we are moving on to the next page, which is giving us a table of coordinates. It says the table below lists the coordinates of 4 different points. Right, so you have the point 1, 5, 2, 7, 3, 9, and 4, 11. It says if x represents any number in the first column, obviously, right? X is right here. Columns go up and down, right? And then it says which expression can always be used to find the value of y in the second column. So they're asking for you to find the relationship between x and y. So this will become more and more prevalent as you guys get older when you're graphing lines and stuff. So let's see, it says if x represents any number in the first column, pretty self-explanatory, which expression can always be used to find the value of y in the second column? So what do we have to do to x to get y? So choice 1 says if we take 5 and multiply it by our x value, that'll give us y. So a lot of kids are going to say, oh yeah, 5 times 1, that gives me a y value of 5. Yeah, that first one works. So yeah, that works for this one. Let's look at if we try it with this group. 5 times 2. 5 times 2 is 10, not 7. So that all of a sudden does not work. All right? So A does not work. Let's look at B. So if we take our x value, let's say 1 in this case. 1 plus 2, that means my y value should be 3 right here. Well, it's 5. So that isn't going to work. All right? It has to be true for all of the numbers in this table. All right? So x plus 4. So again, you're going to have kids that say, oh yeah, look at 1 plus 4 equals 5. Well, 2 plus 4 equals 6, not 7. So this is incorrect. All right, so choice C is incorrect. The process of elimination again tells us it's D. Let's just double check. All right, so 2 times x plus 3. So I'm going to multiply this number by 2, add 3 to it, and I should get this number. So 2 times 1 is 2. 2 plus 3 is 5, all right? How about 2 times 2? That's 4. 4 plus 3 does equal 7. So it's good there, it's good there. 2 times 3 is 6. 6 plus 3 equals 9. Yep. 2 times 4 equals 8 plus 3 equals 11. Yes, it does. So when you actually do some work on that one, you will notice that D is the only one that works all of the time. All right? So again, you're looking for a rule that has to apply to all of them. Number 12, it says which expression is represented by the phrase the square of y decreased by the quotient of 28 and 7. So let's see, it says which expression is represented by the phrase expression. So we're looking for an expression that represents this. The square of y decreased by quotient of 28 and 7. So you guys are going to essentially be translating an algebraic expression here. So we're going to put the English into algebra. So we have the square of y. So if you think of what we know about if we square something, we are multiplying it by itself. So the square of y would be y squared. So you look down here, they all have a y squared. So that didn't help us too much. But, so we have y squared decreased by. When you see the term decreased by, that means we are subtracting. Right? The quotient of, that means I'm going to divide something. So I'm going to have something on the top and bottom of this. The quotient of 28 and 7. So you are looking for choice B. Okay? let's see where you guys would have made mistakes here. The first one could be y squared less than the quotient of 28 and 7, but that's not what it says. Choice C could be the quotient of 28 and the quantity 7 minus y squared. That's not what this says either. And choice D says 28 divided by the quantity y squared minus 7. So really the only even close answer is choice B. So I hope that you guys did a really nice job on that, and hopefully you guys have a better understanding, even though I am not here to help you individually. If you have any questions, please write them down and save them for me, because I will be back eventually. So anyway, I'm going to give you a few more examples in case there's extra time. Right now we're at about 26 minutes into this video, almost, in 8 seconds. And, you know, the class is about 40. So we have 10 minutes of spare between the bell ringer time and attendance. You probably don't have a lot of time. So under number 12, let's do maybe something about combining like terms again. Some kids were struggling with that yesterday. So 2x minus x plus 5 minus 3 plus 7x, right? So when you have an expression like this, you'll often be told to simplify. That means write it in as few terms as possible. So we need to look for things that are all the same. So I notice that immediately some of these have x's attached, all right? So I can only combine things that have the same set of variables. In this case, 2x minus the 1x plus 7x. Those all have x's, so I can combine these. So 2x minus x and plus 7x. So I'm going to look at the positive ones first. 2x plus 7x, that's going to give me 9x. 9x minus x is going to give me 8x, right? If I have plus 5 and and minus 3, those are in the numbers only club, right? There's no x's attached, so they can't be combined with the x. So we have 5 minus 3, that's going to give you plus 2. So your answer here would be 8x plus 2. This is an expression that is made up of two terms, all right, that cannot be combined. You cannot say 10x. You cannot say 10. It's 8x plus 2. Let's say x is a coin, right? So if we had 8 coins plus $2, you can't say that you have $10, all right? You might have 8 pennies and $2, right? That's only going to give you $2.08. So you can only combine things that have the same exact set of variables. So, you know, you can only combine xy's with xy's, but not with just x's and not with just y's. So in this case, you'd have 2 xy's plus an x plus a y. All right? So that would be another example. All right? Another quick example. Let's do b's and c's. So a b plus a b plus a b minus a c minus a c minus a c. You can combine these three. We have 3 b's. All right? And I have 3 c's, but I'm subtracting all of those c's, so I'm going to subtract 3c. All right? Can't be combined because they are not like terms. Don't forget to like and subscribe if you haven't already. I hope you guys have a wonderful day, and thank you for being so helpful and good. The substitute will give you your homework. Bye.